We're at GoToMath.com, working some application problems involving linear equations. Okay, so we got, what is this, 8.1? We got Tuna Dave out there in the Atlantic. If you don't know who Tuna Dave is, I'm not going to go into any further details on that. So, there might be a couple of them actually. Maybe you just read my Twitter feed and you'll figure it out. Anyway, has collected some data and needs to derive a formula such that the temperature is related to depth. I think these guys actually fish fairly not too far off the surface, but I'm not exactly sure where they're tuna fishing at. I don't know. But anyway, I guess Dave was bored that day. Dave's son. We're narrowing Dave down. Since he's home from college, he's got to put his math skills to use here. Okay. So anyway, Dave found that below 3 meters, the temperature decreased 1.5 degrees Celsius for each additional 20 meters. Now, that's a hidden rate right there. At 3 meters, the water temperature is 20 degrees C. I did this problem a minute ago, had to redo it because this number was 60, and when I looked up 60 degrees C, it was like 140 degrees Fahrenheit. I thought that doesn't sound right. Anyway, at what depth is the temperature? 0 degrees Celsius. So we want to figure out what depth is the temperature actually about freezing. That'd be 32F. Anyway, if you want to do that conversion there. Alright, so let's go over to the whiteboard and check out what this data that Joe collected. Anyway, so what do we got going on here? We're going to go ahead and write this out. Now, we haven't got to the point where we're given some points and we're going to construct a linear equation. We haven't got to that point yet in our math career. So we're just going to treat it like this. So we have 1.5 degrees, and you know what? There should be a degree symbol right there. I don't know why that didn't get converted over when I did the copy and paste thing. Anyway, we got 1.5 degrees C for each additional 20 meters. So I don't know how realistic this is there, Joe, but we're going to go with it. We're going to let depth minus 3. I'll explain that here in just a second. And then plus at 3 meters the water temperature is 20 degrees C. Okay. Now, at 3 meters the temperature decreased. So you see this word right here, this is important, decreased, because that means that the rate is actually negative. See that? It decreased. If it says increased, then we'd leave this alone right here. It would be considered a positive rate, but temperature decreased, we throw a negative in there, or we're going to get some messed up numbers. Okay, so now at 3 meters the water temperature is 20 degrees C. If I put a 3 in here, alright, that would be 3 minus 3 is 0, and therefore 0 times this is 0, and the temperature would equal 20, just like it says right here. Alright. So let's just consider this to be, let's say, the top of the ocean. Let's give it a little green tint. And maybe there's some reflections in the water. Yes, I'm an artist. Alright. If we go down 3 meters, that's where, alright, we're going to go down 3 meters. We got a lot of fluctuation in temperature in this particular area right here. So that's the reason we're going down 3 meters. And according to our data, this is obviously not to scale here, but for each additional 20 meters, okay, we have a decrease of 1.5 degrees C for each 20 meters that we go down. All right, so that's going to be considered our rate, and let's go ahead and simplify that or rewrite it. So that's 1.5 degrees C per 20 meters. Right, we consider that to be a rate. And we're going to rewrite that as a negative, we can write it as a 0.075, right? So this is degrees Celsius per meter. Okay, so you see why that's a rate. And D minus 3 plus 20 And you can go ahead and, once you're out there in the Atlantic, get your own data. You'll know how to do it now. And see how accurate it is if you can hit go the depth. You got enough line, I guess. Let's go ahead now. We said when the temperature, okay, at what depth, this is what we're trying to find. At what depth is the temperature 0 degrees Celsius? So we're going to let the temperature be 0, and then what we're going to do is solve for D here. Solve for D. So let's bring that 20 over. We'll divide by, and by the way, that'd be negative here. We divide by the negative 0.075, and that's going to give us D minus 3. Alright, and then let's go ahead and get that. So it's going to be 200 divided by 0.075. And what do we got going on there with that? I'm going to go ahead and leave that as 800 over 3. That's what I'm getting there, so we get a more accurate. And then go ahead, add 3 to that, and that'll be our distance. And I guess we'll go ahead and round this thing. So we'll say approximately, little squigglies means approximate, 269.67. We'll round it to 2 decimal places there. And remember that this is meters, okay? That this is in meters. Don't forget your units here. 269.67 meters. Alright. Yeah, so you want to convert that over to feet if you don't know what that is. And of course I looked up how deep, what the average depth of the Atlantic is, and well, let's just say it's pretty darn deep out there, like 8,000 meters or something. I mean, it's crazy how deep it is out there. Okay, so Tuna Dave put his son to use, all them college skills he's got now. Alright, anyway, we're over here at gotomath.com doing a little modeling, and I guess I'll see you in the next problem.